Introduction. Students, look at this pizza. Can we find the distance around this pizza? The answer is yes. We can find the distance around this pizza. And can we find the space inside this circle? Again, the answer is yes. Do you know what do we call the distance around the pizza? Or what do we call the space inside the circle? Today we will talk about circles in detail. Come, let's begin. Objectives. At the end of this lesson, you'll be able to define perimeter and area of a circle, write areas of sector and segment of a circle, calculate areas of combinations of plane figures, perimeter and area of a circle. A review. The perimeter of a circle is called the circumference. The circumference is the distance around the circle. The ratio of circumference with its diameter is constant. The constant ratio is denoted by pi, or circumference, which is equal to pi into diameter, which is equal to pi into 2r, where r is the radius of the circle, which equals 2 pi r. Pi is an irrational number whose value to 15 decimal places is pi equals 3.14159265358979. We usually say pi is approximately equal to 3.14. The area of a circle is found to be pi r square, where r is the radius of the circle. Example 1. A circular flower bed has a radius of 9 meter. Find the perimeter or circumference of the flower bed. Solution. We know that perimeter P is equal to 2 into pi into r. Substituting the value we get, P is equal to 2 into 3.1416 into 9, which is equal to 56.5487 meter. So, the perimeter or circumference of the flower bed is equal to 56.5487 meter. Example 2. Find the perimeter and area of the circle if the radius of the circle is 8 centimeter. Solution. We have given the radius, which is 8 centimeter. So by using the formula of the perimeter of the circle, we have P is equal to 2 pi r. P equals 2 into 3.14 into 8. P equals 50.24 centimeter. And for the area of the circle, A is equal to pi r square. A equals 3.14 into 8 square. A equals 200.96 centimeters square. Example 3. The wheel of a bullock cart has a radius of 60 centimeter. If the wheel rotates once, how much distance does the cart move? Solution. If the wheel rotates once, the cart will move by a distance equal to the perimeter of the wheel. We know that P is equal to 2 pi r. Now, by substituting the values, we get P is equal to 376.8 centimeter. Thus, the bullock cart moves 376.8 centimeter in one revolution of the wheel. Areas of sector of a circle. There are two main slices of a circle. The pizza slice is called a sector, and the slice made by a chord is called a segment. We can work out the area of a sector by comparing its angle to the angle of a full circle. A circle has an angle of 2 pi and an area of pi r square. So a sector with an angle of theta instead of 2 pi must have an area of theta upon 2 pi whole into pi r square, which can be simplified to theta upon 2 into r square. Area of sector is equal to 1 upon 2 into theta into r square when theta is in radians. Area of sector is equal to 1 upon 2 into theta into pi upon 180 into r square when theta is in degrees. Arc length. By the same reasoning, the arc length of a sector or segment is L is equal to theta into r when theta is in radians. L equals theta into pi upon 180 into r when theta is in degrees. Area of a segment of a circle. The area of a segment is the area of a sector minus the triangular piece. Area of segment is equal to 1 upon 2 into theta minus sine theta into r square when theta is in radians. Area of segment is equal to 1 upon 2 into theta into pi upon 180 minus sine theta into r square when theta is in degrees. Example of areas of sector and segment of a circle. A chord of a circle of a radius 10 cm subtends a right angle at the center. Find the area of the corresponding 1. Minor segment, 2. Major sector. Use pi as 3.14. Solution. Let AB be the chord of the circle subtending 90-degree angle at center O of the circle. Area of major sector OADB is equal to 360 degree minus 90 degree whole upon 360 degree into pi r square, which equals 270 degree upon 360 degree into pi r square, which is equal to 235.5 centimeters square. Area of minor sector OACB is equal to 90 degree upon 360 degree into pi r square, which is equal to 78.5 centimeters square. Area of triangle OAB is equal to 1 upon 2 into OA into OB is equal to 50 centimeters square. Now, area of minor segment ACB is equal to area of minor sector OACB minus area of triangle OAB, which equals 78.5 minus 50, which becomes 28.5 centimeters square. Example. In a circle of radius 21 centimeter, an arc subtends an angle of 60 degree at the center. Find 1. The length of the arc. 2. Area of the sector formed by the arc. 3. Area of the segment forced by the corresponding chord. Use pi as 22 upon 7. Solution. Radius r of circle is equal to 21 centimeter. Angle subtended by the given arc is equal to 60 degree. We know that the length of an arc of a sector of angle theta is equal to theta upon 360 degrees into 2 pi r. Therefore, length of arc ACB equals 22 centimeter. Area of sector OACB is equal to 60 degrees upon 360 degrees into pi r square. Now, by substitution and calculation of the values, we get area of sector OACB is 231 centimeters square. In triangle OAB, angle OAB is equal to angle OBA, as OA is equal to OB. Angle OAB plus angle AOB plus angle OBA equals 180 degree. 2 into angle OAB plus 60 degree equals 180 degree. Angle OAB is equal to 60 degree. Therefore, triangle OAB is an equilateral triangle. Area of triangle OAB is equal to square root 3 upon 4 into side whole square. By calculating, we get area of triangle OAB is equal to 441 into square root 3 divided by 4 centimeters square. Area of segment ACB equals area of sector OACB minus area of triangle OAB, which is equal to 231 minus 441 into square root 3 divided by 4 whole centimeters square. Example. An umbrella has 8 ribs which are equally spaced, see figure. Assuming umbrella to be a flat circle of radius 45 cm, find the area between the two consecutive ribs of the umbrella. Use pi as 22/7. There are 8 ribs in an umbrella. The area between two consecutive ribs is subtending. 360 degrees upon 8, which is 45 degrees, at the center of the assumed flat circle. Area between two consecutive ribs of circle is 45 degrees upon 360 degrees into pi r square. Now, by calculating it, we get 22,275 upon 28 centimeters square. Areas of combinations of plane figures. We have learned to calculate the areas of different figures separately. We will now learn to calculate the areas of combinations of figures. Let's solve some examples. Example. Find the area of the shaded region in the given figure if the radii of the two concentric circles with center O are 7 cm and 14 cm respectively, and angle AOC is 40 degree. Use pi as 22/7. Radius of inner circle equals 7 cm. Radius of outer circle equals 14 cm. Area of shaded region is equal to area of sector OAFC minus area of sector OBED, which is 40 degrees upon 360 degrees into pi into 14 square minus 40 degrees upon 360 degrees into pi into 7 square. Now, by substitution and calculation of the values, we get area of shaded region is 154 upon 3 centimeters square. Areas of combinations of plane figures. Example. From each corner of a square of side 4 cm, a quadrant of a circle of radius 1 cm is cut, and also a circle of diameter 2 cm is cut as shown in the given figure. Find the area of the remaining portion of the square. Use pi as 22/7. Each quadrant is a sector of 90 degree in a circle of 1 cm radius. Area of each quadrant is 90 degrees upon 360 degrees into pi r square, which becomes 22/28 centimeters square. Now, area of square is equal to side square, which equals 4 square, which is equal to 16 centimeters square. Area of circle is equal to pi r square equals pi into 1 square, which is equal to 22/7 centimeters square. Area of the shaded region is equal to area of square minus area of circle minus 4 into area of quadrant. Now, by substitution and calculation of the values, we get area of the shaded region as 68/7 centimeters square. Did you know? A circle is a conic section cut by a plane perpendicular to the axis of the cone. The term circle is also used to refer to the region enclosed by the curve, more properly called a circular region. The radius of a circle is any line segment connecting the center and a point on the curve. The term is also used for the length r of this segment, that is, the common distance of all points on the curve from the center. Similarly, the circumference of a circle is either the curve itself or its length of arc. A circle is inscribed in a polygon if each side of the polygon is tangent to the circle. A circle is circumscribed about a polygon if all the vertices of the polygon lie on the circumference. Summary. Let us summarize what we have learned. Circumference of a circle is equal to 2 pi r. Area of a circle is equal to pi r square, Length of an arc of a sector of a circle with radius r and angle with degree measure theta is theta upon 360 into 2 pi r. Area of a sector of a circle with radius r and angle with degrees measure theta is theta upon 360 into pi r square. Area of segment of a circle is equal to area of the corresponding sector minus area of the corresponding triangle.